In this screencast, I'm going to describe what is perhaps the most important aspect that needs to be considered when we're looking at designing polymerization reactors. The question is, how does the type of reactor affect the molecular weight distribution? Of course, the molecular weight distribution affects quite a bit the properties of the final polymer that's made. So let's look at the question. We have two molecular weight distributions. We're plotting the percent of polymer. So this is the percent that each polymer, a polymer with 100 monomer units has 0.4% in this distribution, for example. Two different distributions, one broad, one narrower. And the question is, if we're starting out by assuming that one of these corresponds to a continuous stirred tank reactor, and one corresponds to a plug flow reactor, which molecular weight corresponds to which reactor? Well, the answer is that it depends. And it depends on which type of polymerization we're carrying out. And so there are really three things we have to take into account as to what affects molecular weight distribution. One is the residence time distribution. Plug flow reactor and CSTR have different residence time distributions. The other is the concentration at which the reaction takes place. CSTR has a constant concentration. During all reaction, a plug flow reactor, the concentration changes with time. And the third is the chain growth time. So we're going to look at the two extremes and then compare reactors. One extreme, the chain growth time is much longer than the average or mean residence time in the reactor. And the other, the chain growth time is much shorter than the mean residence time in the reactor. So we'll start out and let's look at the case where the chain growth time is much larger than the mean residence time in the reactor. For example, condensation polymerization, where the polymer keeps growing, in the case where no termination step, keeps growing as long as it's in the reactor. So there, in this case, the chain growth time is much longer than the mean residence time. Let's see what happens in a plug flow reactor. Of course, the same behavior would be expected in a batch reactor because they have the same residence time distribution. So the important thing about the plug flow reactor, all molecules have the same time in the reactor. If we assume it's ideal plug flow, then every molecule spends, for example, 15 minutes in the reactor. And what this means then is all molecules have the same reaction time. And so if the chain growth time is large, relative to mean residence time, this means we're going to get a narrow molecular weight distribution for the plug flow reactor. So this would correspond to the plug flow reactor. CSTR, on the other hand, has a very broad molecular weight distribution. The distribution as a function of time is an exponential decay. Some molecules spend a very short time in the reactor. They can't make very long polymers. Some spend a very, very long time in the reactor. They make very long polymers. As a result, CSTR is going to give us the broader molecular weight distribution for the case the chain growth time is large. Let's look at the other extreme where the chain growth time is small. So chain growth time small relative to mean residence time. This could be a free radical addition type polymerization where there's a termination. The actual time that the free radical growing polymer chain exists may be in the order of seconds or less. Then we have very short chain growth time. This means rather than the residence time distribution affecting the molecular weight distribution, the concentration at which reaction takes place. So what's going to happen is in a plug flow reactor, the monomer concentration changes as we move down the reactor. In a CSTR, on the other hand, the monomer concentration is constant. And because of this, all reaction takes place the same monomer concentration. Therefore, the termination rates are going to be uniform, and we're going to get a narrow molecular weight distribution. So then this would be behavior in a CSTR. In the plug flow reactor, we're going to have a changing concentration of our active species because the monomer concentration changes and their concentration depends on the monomer concentration. And therefore, we're going to have varying termination rates. And this is going to give us a broader molecular weight distribution. So in this case, plug flow reactor is going to give the broader distribution. And so very much which type reactor we pick is going to depend on which type of polymerization reaction we're carrying out. And we see these broad or narrow distributions could be either a CSTR or a plug flow reactor depending on the type of polymerization.